In the name of Allah, the most gracious, most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your exceptional support to make this channel a grand success. We are a partner and a family. Please subscribe and share our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunity into success stories. These success stories can be monetized into value addition. Thank you very much for your precious time. Okay, today we are going to discuss lecture number 7 on smart grid control challenges model. Before my lecture, I used to read a Quranic verse. Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli rabbi zidni ilma. As we have promised, we have to deliver 100 lecture on smart grid control and operational challenges. Okay. On my next slide, I will give my special gratitude of my faculty members and my professors whom I worked many years, and then I will describe my 100 lecture program, and later on I will give highlights or key takeaway, and then I will run a complete trail on my lecture number 7. This is my acknowledgement page. I pay my special gratitude all faculty members, in particularly Professor Dr. R.K. Agarwal, former Director of Center of Sustainable Power Distribution, University of Abbottabad. He was my supervisor. I worked with him more than 12 years. Professor Dr. Abdullah Adris Alaid, a former APRI Senior Technology Manager, California, USA. So he was my mentor and external supervisor. Unfortunately, he passed away in 2016. Almighty Allah bless him, highest place in Jannah. Professor Dr. Muhammad Afzal Haq, Professor Dr. Nad Mohan, Professor Dr. Florin Pamtu, Professor Dr. Muhammad Jambal, Professor Dr. B.S. Chaudhary, Professor Dr. Nasir Imadi, Professor Dr. Akhtar Kalam, Head of Smart Technology from Victoria University, Australia, Professor Dr. Suhail Aftab Qureshi, former Dean UT Lahore, Professor Dr. D.P. Qatar, Professor Dr. Abdul Jabbar, CO ADP, Pakistan. Today I am going to discuss my lecture number 7. Before my lecture, I will give you a brief highlight what we have discussed so far. So in my lecture number 1, we have discussed electricity for our civilization, electric power functionality, energy efficiency from generation to consumptions, ultimate goal for smart grid. In my lecture number 2, we have discussed a power system infrastructure, development, power system complexity, power system limitation, reactive power significance and management. Lecture number 3, we discussed reactive power management, challenges to manage reactive power, balanced reactive power and challenge at AC power system. Lecture number 4, we discussed dealing with thermal limit, increase transmission conductor current carrying capacity, DTCR, dynamic thermal circuit rating technology. Number 5th, we have discussed first generation compensators, mechanical switch capacitors, reactors, and second generation compensator, that is, and third generation compensators. Okay, on my lecture number 6, we have discussed the impact of dynamic voltage support, fault induced delay voltage recovery phenomena, FIDVR, STATCOM ensures voltage recovery, sub-synchronous resonance SSR phenomena. Okay, so today we will run a complete trade on my lecture number 7. Before my lecture number 7, I will give you my 100 lecture plan on my next slide. Okay, this is my 100 lecture plan. So during my 100 lecture, we will discuss FAX technology concept, power semiconductor devices, voltage source converters, self and line commutated current source converters, SVC and STATCOM operations, static series compensators, static voltage and phase angle regulators, combined compensator UPFC, special purposes fax devices, and application example. I will give you a couple of example fax devices already implemented in United States of America. So what we need to understand fax concept and technology. What is delivery? First, we will describe shaping the global energy delivery, faxed on resolving a gridlock or stalemate of the power system, and delivering a clean and pure power energy. That will be the ultimate goal of when we have complete our 100 lecture. We will witness the following outputs. Okay, these are the key takeaway points from lecture number 7. Today we will describe a third generation fax device. First we will discuss TCSC, structure and functionality, and then we'll discuss operational characteristics, and then we'll discuss fundamental of voltage source converter. These are 3 concepts we will discuss today in lecture number 7. Okay, this page dedicated to faculty member and student, in particularly leadership and department chairs, dean and VCs of universities as listed below. University of Engineering Technology, Lahore, Pakistan; NFC University of Chemical Engineering, Multan, Pakistan; RCT Gujranwala; Mehran University, Jamshoroo; NED Karachi; Habib University, Karachi; University of South Asia, Lahore; National University Engineering Technology, Nasta, Islamabad; International Research, Islamabad; Karachi Electric; IPFC Qatar sections; University of District Columbia, USA; University of Texas Arlington, Dallas Fort Worth, USA; Texas Tech University, Lubbock; University of Abbottabad, Qatar University, Qatar; Texas A&M University, Qatar campus; University of Granada, Spain; University of Salamanca, Spain; COMSATS, Abbottabad, Pakistan; and City University, Peshawar. Okay, reactive power compensator, we have discussed lecture number 1, 2, 3, 4, 5 and 6. We have discussed first, second and third generation compensators. Okay, what is the difference between first, second and third generations? The first generation compensator basically mechanical switch capacitor and reactors, and it constituted with the breaker delays or breaker based compensators. So the second generation compensators is thyristor controlled reactors and thyristor switch capacitors. So it will take 2 to 3 cycles, thyristor based controllers, and third generation compensators that it will take 1 to 2 cycles. That is basically STATCOM, SSSC, UPFC. That is third generation based on converter based control devices. Okay, just a recap. If you can see here, this is my V1 generation side voltage and V2 is my load side voltage. Okay. So the system is operating at 4 conditions. First is a heavy load, or we can say operating scenario, light load, outage of one line, and load rejection. Okay, these 4 conditions we have demonstrated in the graph here: A, B, C and D. Okay, so A, B, C, D also showing the orange here, the legend which demonstrated without fax devices or without STATCOM SVC. Okay, on the left hand side you can also see the capacitor inductor mode of operation. What basically STATCOM is doing? STATCOM has 2 functions: capacitive reactive power compensations behavior, electrostatic behavior, that is function of V, and secondly this is also known as the inductive reactive power compensation behavior of electromagnetic field, that is function of I. Okay, now if the capacitor is greater than the inductor, so what could happen? So it indicates this may lead to have over voltage risk. If the inductor is greater than capacitor, so this may lead to have a voltage instability or low voltage. Okay, now if you can see in the operating scenario A without SVC or STATCOM, so as load increase, so your voltage dropped here. In the B category, if you can see here, as load reduced, your voltage increase. It's mean capacitor more than inductive. When the voltage drop, it's mean inductive is greater than the capacitive. In B here, B operating condition here, if you can see here, So when the one line is dropped, this line is isolated or outages, so then it's mean inductive is greater than capacitive. Okay, so the voltage drop from 1 per unit value to 0.8. Similarly, in a D condition, load rejection, when load rejected, so the capacitor is greater than inductive, so the voltage, if you can see, voltage increased up to 1.2 per unit value. Okay, the maximum voltage control range depend on Q over SEP. So that is our maximum operating limit. Okay, so now on my next slide, I am going to give you a TCSC operations, and then we will discuss further voltage source converter, and then we will conclude our today presentation. Okay, thyristor control series capacitors and functionality. Okay, what it basically demonstrates here. So this is my sending end voltage, and this is my receiving end voltage here, Vs and Vr. Okay, this series capacitor is used to adjust the impedance, to control the impedance. When we control the impedance, so your transmission angle can be controlled, can be managed. We can adjust the transmission angle to deliver a maximum power. Okay, by adjusting the current controls, so we can increase a power flow controls. Okay, now if you can see here, the capacitor have a VC. What is VC basically? This is known as a capacitive reactive power compensation behavior electrostatic field, that is function of V, as we have demonstrated here, VC in the waveform here. Okay, second is the current control. It will adjust to increase the power flow control. This is also known as the inductive reactive power compensation behavior electromagnetic field or function of I. Okay, so by adjusting a thyristor control firing angle greater than 180 degree, so you can inject a maximum voltage in series to reduce the line impedance or line reactance. So by reducing a line impedance, so your transmission angle will be reduced. So Vs and Vr angle from sending end angle to receiving angle will be reduced. When we have less angle, or when we have a small angle between VSR, you can deliver or you can transmit more power. If you can see on my right hand side, this is my V1 and this is V2, and this is my load angle. V1 is a sending end and V2 is a receiving end voltage. Okay, so this is my load angle between V1, V2 or Vs or Vr. Similarly, so as we injected a voltage in series, a VC, so what would happen? Your V1 and V2 load angle reduce. When the load angle reduced, you can inject, you can transmit maximum power into the networks. So it can help to increase a power flow into the transmission network if you have a series compensator or series capacitor. What TCS can help? Can damp up power oscillations, number 2, and number 3, it can mitigate SSR. So TCSC has a capacity to mitigate the SSR phenomena. Okay, current control a load flow, operation characteristic of TCSC. Okay, what is TCSC? Basically, it has two operating phenomena. First, this is known as a capacitive reactive power compensation behavior electrostatic field function of V. Okay, and secondly is as an inductive reactive power compensation behavior electromagnetic field function of I. This is the what TCSC is doing, capacitive mode of operation and inductive mode of operation. Okay, on my graph here, so by controlling current, we can adjust the load flow. By controlling a line impedance, we can adjust the transmission angle. Okay, if you can see here on my impedance a function of the firing angle on my graph here. Okay, as we have adjusted from 0 to 130 degree firing angle, so the system remain into inductive mode of operation. So inductive mode of operation mean, so your inductive is greater than the capacitive, so there could be after reaching a certain level there could be a voltage drop, then suddenly is switched over to capacitive compensations due to some reason. So then the angle is 150 to 180 degree. So mean capacitive is greater than inductive. So the again the voltage improve and system remain into stabilized conditions. Okay, what is the middle here? This is a forbidden area, so we cannot operate the system here. This is where there is a resonance here. So this is the forbidden or resonance area where we cannot operate TCSC operation. Okay, the voltage source converter. This is my last slide for today's lecture. First, it demonstrates here the voltage source converters control topology, and VO is my output voltage. Bottom here we demonstrate a 3 level of the voltage source converter control topology, and this is my also a firing angle. So on the right hand side we have demonstrated pulse width modulation at a 12,000 frequency to adjust the firing angles, and over here a transmission network here, and this is my voltage source converters with a DC capacitor here. Okay, voltage source converter with controlled output voltage. So VL is my line voltage and V0 is my the converter output voltage. If VL is equal to V0, so the I will be 0, there will be no flow of current. If VL, the line voltage, is less than V0, so there I will be capacitor mode of operation. You have to adjust a capacitor mode of operation. If VL is greater than V0, then you have to adjust the inductive mode of operations. So then it will be inductive mode of operations. Thank you very much for your precious time. Today we have discussed. So on my next lecture we will discuss 3-level quasi-harmonic neutralized 48 pulse modulations and fundamental structure of voltage source converter. Thank you very much for your precious time. Okay, today we have discussed TCSC structure and functionality, TCSC operational characteristics, fundamental voltage source converter. Thank you very much for your precious time. We are still working on shunt and series controllers functionalities. Okay, these are references, the paper which I have published in different conferences and journals. Thank you very much for your precious time. Together everyone achieve more. Please don't hesitate, send me your feedback and comments t.masood.dr@bath.edu. Please stay at home, safe, inspired and blessed. Thank you very much again for your precious time.